In the last section, we looked at how nebulae form stars, that you have these dense clouds of dust and gas, and that's where stars form. Now we're going to take a closer look at the result of that star formation, starting with the idea that these clumps of dust and gas, gravity will bring them together. But astronomers aren't always sure that that's actually enough to ignite fusion, to actually have star formation that way. One way that we know for sure that new stars are triggered is when you have an exploding star, supernova, and the shock wave from that supernova they know can ignite new stars, which I think is kind of poetic, that the death of one star leads to the birth of many more. Another way that we know of that can trigger star formation is when galaxies collide with each other. And the pressure from that can also trigger a lot of new star formation. So they're still researching what exactly is that extra push that allows enough pressure to ignite fusion. But the point is here that stars will form inside these giant clouds. So they tend to form in groups, giant groups of stars. And that, of course, would include our sun. So we believe that billions of years ago, our own sun must have formed in a cloud like this and with other stars. And I think it's kind of interesting that after 400 years of modern astronomy, we actually don't know who our sibling stars are. We don't know which stars were born with our sun from that ancient nebula. Kind of interesting. They've had a long time, 4.5 billion years, to scatter around the galaxy. Now, when those stars form in groups, you will have a lot of small mass stars, low mass stars, red dwarfs, and you might, have a few sun-like stars, and maybe one or two blue giants, very high mass stars. But something else that you will have formed that kind of gets overlooked are what we call brown dwarfs. Brown dwarfs are made of hydrogen and helium like stars, but they don't quite have enough material, enough pressure to maintain fusion. They might even have fusion for a short time, but they can't sustain it. So sometimes we say these are failed stars. And even though they kind of get ignored, we should remember that they are probably very plentiful in our galaxy. There are probably billions or tens of billions of these brown dwarfs. The problem is, here we see one compared to the size of Jupiter, a large planet, and then we see it compared to the size of a small red dwarf star, and they're kind of an in-between thing. But if they're off on their own, they're going to be incredibly hard to detect because they don't generate light. So we're not going to find them. And unlike a planet that's reflecting the light of its host star, when a brown dwarf is off on its own, it's going to be nearly impossible to find. So we kind of tend to ignore those, but there are billions of them out there. So when stars form, they form in what we call a cluster. And clusters, astronomers love to study clusters. One reason is that the stars within the cluster have certain things in common. They were born from the same cloud of material, so they have a similar composition. They were born at the same time, and that decreases the number of variables that they have to look at. It's kind of like when we might study, if we're studying a genetic disease, you might choose as a researcher to study a town, some remote town, where the townspeople have very similar genetic codes because there are fewer variables there to look at if you're trying to pinpoint, let's say, a genetic disease of some type. So astronomers look at clusters kind of the same way as a good laboratory to study stars. There are two major types of star clusters. The most common type are called open clusters. There are over 30,000 of them in our galaxy alone. They're very plentiful. You can actually just scan the skies with binoculars and just find them randomly there in the sky. I do that many times at our astronomy nights. These clusters can have hundreds or even thousands of stars, but they're still the smaller of the two types of clusters. And because they don't have as many stars, they don't have as much gravity, and so they are more loosely bound. They don't have a particular shape like a sphere or a disk. They tend to be a little more loosely shaped. And because of that, because they aren't as tightly bound, they also don't hang together as long. They're going to separate after a fairly short time. So all open clusters are young. That's something they have in common. They can't stick together for that long, And so they might be 100 million years old, let's say, which again, in galactic terms, is young. In a galaxy that might be 10 billion years old, having an open cluster 100 million years old is actually very, very young. The open cluster that I want my students to know is the Pleiades. It is so easily seen with the naked eye. Has a cool nickname, the Seven Sisters, even though most people actually just see 6 stars oftentimes. And one of the common things I hear, kids will say, oh, I saw the Little Dipper last night. And they're actually seeing the Pleiades cluster. Here it is right in the middle of the screen. This is a picture that I took at our local park with just a camera, no telescope or anything, just to show kind of what it looks like to the naked eye. Here it is zoomed in with our telescope in our classroom, and you can see the major stars there, but then you see that there are actually dozens of other stars in the Pleiades. Here is just a magnificent view of the Pleiades, and you can see how young they are by the amount of dust and gas actually that's still left over. The Japanese word for Pleiades is Subaru. And so when you see a Subaru car, you notice here they have the symbol there representing the Pleiades cluster. Kind of neat. Here's the Christmas tree cluster, another picture that I took. That's the star at the top of the tree. The tree comes down here, comes down there. That's the base of the tree. Christmas tree cluster. And then one of my very favorite backyard telescope sites is the double cluster, which is here and here. It kind of has 2 downtown regions. Love the double cluster. Let me show you a great picture here of the double cluster from somebody much more adept at astrophotography than myself. Love this shot here. Here you see how a very young cluster, and there's still a lot of the nebula left over. And you see some galaxies in the background of this picture. Just a gorgeous, gorgeous picture. Okay, another very busy region of space showing lots of different things that we've talked about here lately, different types of nebulae and clusters. The other major type of cluster are called globular clusters. They're globular, they're named so because of their globe shape, their spherical shape, and as you can probably guess, they have more stars than the other type of cluster, which is what makes them spherical. More gravity gives them a spherical shape. I think the most interesting thing about them is their orbit. Everything else rides around the galaxy like it's going around in a carousel, in a fairly flat plane, kind of bobbing up and down a bit. But everything we've talked about, every nebula, every star cluster, every individual star, and ourselves, our own solar system, go around in the plane of our galaxy on a fairly flat frisbee. But globular clusters are out doing their own thing. They look more like electrons, the old picture of electrons going around the nucleus of an atom in every which way. How is that possible? Well, astronomers think that it's tied in with the fact that they are very, very ancient. Globular clusters, astronomers believe, were formed before the galaxy flattened out. What I like to call the law of pizza dough. Okay, a spinning galaxy early on would flatten out, but these globular clusters had already achieved orbits, spherical orbits around a spherical galaxy. And so when the galaxy flattened out, they didn't go with it. They didn't flatten out with it. That is the theory. And we have some good evidence that these clusters are incredibly old. Why? Because the stars within them are incredibly old. You have a whole bunch of red giant stars, which are what I like to call retirement age stars, and you have a bunch of white dwarfs, which are kind of nursing home stars. There are only about 150 of these mysterious clusters. They're really kind of like mini galaxies, and there are only about 150 of them we found. Astronomers think there might be up to about 200 or so. There are probably some hidden on the opposite side of the galaxy that we can't see. Here's what they look like. Honestly, if you've seen one, you've seen them all. They all look pretty similar. These spheres, they're very pretty, but they all look pretty similar. M3 is one of the largest ones you can see in the northern hemisphere. M13 is in Hercules. That's my favorite one to try to find. It just looks like a little smudge in our school telescope, but at least we can find it. It's pretty far away, probably 20, 30,000 light years away. And finally, the largest known globular cluster, Omega Centauri. I can't show this one at our astronomy night because Centauri, as you can probably guess, is in the southern hemisphere, just like Alpha Centauri. So that's Omega Centauri, the largest known globular cluster. Thanks for listening.